Hello, in this video we are going to be computing the control limits for a P chart where we look at the percentage of products or items that are defective. We start out by assuming that we've been collecting data every day or every hour, whatever. So I'm calling it days, and we need to know how big the sample size is every day. And so here we collected 100 samples and then 80, etc. And then out of all those samples we collected, we need to know what the defect rate is. So if 7 out of 100 are defective, obviously that gives us a defect rate of 7%. 9 out of 80 is 11.3. So we've computed the defect rate every day, and that is what we will be plotting on our graph in a moment. But first we need to know the control limits for this graph. So to do that, we need to calculate several things. We need to know the average defect rate P bar. We need to know the average sample size N bar. We need to know the sample standard deviation S. And then we can compute the upper control limit and the lower control limit using those numbers. So P bar, there are two ways a person could do it, and one of them is wrong. Do not just take the average of these numbers, because that will get you the wrong number and ruin everything. So what we want to do is we want to look at the total number of defective items. We had 37 defective items out of the 500 items that we inspected, and so that gives us a defect rate, P bar, of 7.4%. So of all the things we looked at, the average defect rate, P bar, is 7.4%. To get the average sample size, we look at the total number of items we inspected, in this case 500, divided by the number of times that we went out to collect information. So our average sample size, N bar, is 100. So now we are ready to calculate our standard deviation. So we'll take P bar, which is, I'm going to write it as 0.074, times 1 minus that, so 1 minus 0.074, and then we divide that by our average sample size, 100, and then we take the square root of that, and then you are just going to have to trust me on the math here that the standard deviation is 0.0026. So now we are ready to calculate our upper and lower control limits. And the control limits are simply the average P bar plus or minus 3 times our standard deviation proxy here, our S, our sample standard deviation. So to get our upper control limit, we have 0.074, that was our defect rate, plus 3 times S, 0.0026, and then to get the lower, it's the same process, except we are just going to subtract instead of add. When you work out the math here, we get an upper control limit of 8.2%, and on the lower control limit, we get 6.6%. Now I do have to make one little side note here. When you calculate the lower control limit, it's entirely possible that this minus this could give you a negative number, and it doesn't make sense to talk about a negative number of defects, and if that does happen to you, just use 0 for your number there. Okay, so we have our upper control limit is 8.2, lower control limit is 6.6. Now let's graph our numbers and see what we get. Let's see, we're going from 5% up to a little more than 11%. So our first one, let's see, so 5, 6, 7, 8, 9, 10. Beautiful. So our first day, the sample rate defect rate was 7%. The next day, it's 11.3. And then the next day, we're here at 6.7. And the next day, we're down at 5.3. And the next day, we're up at 7.2. So we will connect our data points here, and then we are going to plot our upper and lower control limit. Our upper control limit is 8.2. So here we are with our upper control limit of 8.2, and what you see, of course, is that we have one data point that is above that. Now let's also graph our lower control limit of 6.6. And I didn't, yeah. Okay, so we have one point that is above the upper control limit, and we have one point that is below the lower control limit. And so this is definitely going to qualify as a process that is not under control and that is worthy of further study. So the first question is, here on day 2, where we had a value that was above the upper control limit, we want to ask our people what happened. Why was the defect rate so high that day? Because it seems like the defect rate was uncharacteristically high. We would like to find out what was going on, and we would like to stop that from happening. But then if we look at day number 4 here, where we were actually below the lower control limit, let's think about what that means. It means the defect rate was too low. It's lower than we expect. We still want to ask our people what happened that day, because maybe everything just went right, and maybe there's something we could learn from this to try to do that every day so we can get our defect rate to be lower every day. So to summarize, we start off with data about how many samples we collected each day, the defect rate, the number of defects each day, pardon me, dividing the number of defects by the number of samples, we get the defect rate for each day. We can then take the total number of defects, divide by the total number of items inspected to get P bar, our defect rate. The average sample size is just the average of these numbers, or 500 divided by 5. And then we calculated S, and that gave us our sample standard deviation. But our control limit is the average P bar plus or minus 3 standard deviations. And so we got 8.2 and 6.6 as our control limits. And we had 1 point too high and 1 point too low. So that's how we calculate control limits for a P chart, and I hope this has been helpful.